Hello everyone. In this session, we are going to see about psychometric and drying. So, first of all, we need to know what is psychrometry. The psychrometric is nothing but the branch of engineering science which deals with the study of moisture air, that is, the dried air mixed with water vapor or humidity. And there are certain basic terms we need to know before entering into the drying subject. So the basic terms are moisture, saturated air, dry, degree of saturation, humidity, relative humidity, dry bulb and wet bulb temperature, and dew point. So these basic terms needs to know before study of dry, because these are the terminologies involved in a drying process. So the capacity of air for which moisture removal depends on its humidity and temperature. So the study of relationships between air and the associated water is nothing but psychrometry. So the psychrometry charts are represented in a graphical form, which represents air properties used for air conditioning and drying calculations. So the uses are nothing but dry bulb temperature and relative humidity. These combinations are useful for determining certain properties. So the combinations are dry bulb temperature and dew point, wet bulb temperature and relative humidity, wet bulb temperature and dew point temperature, wet bulb and dry bulb dew point temperature alone. So the chart will be like this only. So in this chart we can interpret and we can find out the certain values like enthalpy range, specific heat enthalpy, entropy, and dry bulb temperature, wet bulb temperature, dew point temperature for certain air temperatures. So after this, we need to dry the food produces from agriculture process. The drying is a crucial process in post-harvest technology that involves the removal of moisture from agriculture products to enhance their shelf life, which can reduce the susceptibility to spoilage and maintain product quality. And also, this can prevent from growth of microorganisms, enzymes, or any other factors which contribute to decay of the products. This drying is nothing but heat and mass transfer, um, consisting of removal of water or any other solvent by evaporation method. So after threshing, the moisture content of the grains needs to be uh, brings down, because generally after harvesting the moisture content will be higher than safer storage of grains. So this is the drying phase is plays a crucial role in post-harvest technology. The objectives of drying is nothing but extended storage life, lesser storage space, reduced packaging requirements, lower handling and transportation cost, off-seasonal availability, permits farmers to have better quality products. So the principles involved in drying is nothing but diffusion, evaporation, heat transfer, and mass transfer. So these are the basic principles involved in principles of drying, especially heat and mass transfer, because the heat will be applied in the form of either dried air or any kind of form, and because of this the moisture content will be transferred from product to that hot air. So there will be mass transfer and heat transfer. So the theory of drying is nothing but a convection process in which moisture from a product is removed. Water content in terms of moisture content can be removed. Gain or loss moisture from the academic atmospheric conditions. So these are certain theory of drying. And also the drying can takes place in two periods: concentrate period and falling rate period. So the concentrate period is nothing but this graph shows that concentrate period. So from the drying process takes place, first period will be concentrate period, and afterwards first falling rate and second falling rate period will be followed. In this concentrate period, free water will be evaporated, and in first falling rate period, interstitial water will be evaporated, and second falling rate surface water will be evaporated. This is the uh, process or a period which takes place in a drying process. So there are different mechanisms of drying. One is capillary flow, liquid fusion, surface diffusion, vapor diffusion, thermal diffusion, hydrodynamic flow. So based on the product or based on the heat transfer applications, either one of the mechanisms can be takes place. So there are different types of drying process involved in agriculture producers. One is sun drying, hot air drying, mechanical drying, and vacuum freeze, microwave oven drying. There are many kind of drying process involved in this for agriculture commodities. But the drying can take place under two phenomenon. One is thin layer drying, and another one will be deep bed drying. So the thin layer drying is nothing but the layer refers to the grain drying process in which all grains are fully exposed to the drying area or drying air under constant drying conditions. So generally the thickness will be 20 centimeter of grain bed. So all the commercial flow dryers are designed based on this thin layer drying only, because this thin layer drying bed thickness will be limited to 20 centimeter only. So the drying rate is independent of air velocity, and the rate of drying is proportional to the difference between the vapor pressure of moisture in the grain and vapor pressure of moisture in the air. And this will be deep bed drying. So the deep bed drying is nothing but the depth will be more than 20 centimeter. So there are three zones formed in the thin layer drying. One is nothing but a dried zone, and drying zone, and wet zone. So these three zones will be formed because the thickness of the bed will be more than 20 centimeter. And methods of water producing is nothing but a direct method and indirect method. Direct method and indirect method. So indirect method is nothing but fired hot air generators, and heat transfer medium will be used, such as water or oil. Then the air will be heated. In direct zone, fired hot air generators heat air directly with the heat source. Then there are certain types of dryers which has their own operation, own working based on the crops and constructions. There are different types like deep bed, flat bed, continuous recirculatory tray dryer, fluidized bed, LSU, and solar dryers. First one will be deep bed dryer. As we have seen earlier in this session, deep bed drying is nothing but the bed thickness will be more than 20 centimeter, and there are different airflow rates will be recommended based on surrounding area, surrounding temperature, as well as the product. So if the moisture content is more than up to 80%, the layer depth should be limited to 3 meter. For grains whose moisture content is above 18%, the depth will be 2.5. So paddy with 2.5 meter deep layer may take place 20 days to dry during favorable weather conditions. So these are some of the deep bed dryer. And for flat bed dryers, the ton capacity will be vary from 1 to 2 ton capacity, and the bed depth will be like 0.6 to 1.2 meter only. So there is a limited likelihood of over drying the grains. Continuous flow dry is nothing but the grains which flow from the top to the bottom of the dryers. The rate of flow of grains through columns can be regulated by conveyors. So in this there are two types. One is mixing and non-mixing type. So mixing type baffles are provided to cause the grains to mix during the downward flow, and in non-mixing types baffles will not be provided in columns, and drying takes place between two parallel screens. And the air flow rate, volumetric flow rate will be varied based on the type of crops or type of varieties used. Next one will be recirculating dryers. In continuous flow dryers, a multi-pass procedure is used to avoid excessive drying stress. During each pass, the grains are exposed to the heated air for a short time, and about 1 to 3% of the moisture content is removed. Drying temperature will be like 60 to 8 degrees Celsius will be used. So in this process, drying is faster and effective because of the continuous movement of grains during the short drying times. Next one will be dry dryer. So this dryer operates in a batch mode operations because the products will be uh, placed in racks in a chamber, and the air circulation will be over the material. So this consists of a rectangular chamber of steel metal and containing tracks that support racks. So such racks carries a number of trays that are loaded with the material to be dried. Hot air will flow through the tunnel over the racks so that the moisture content will be transferred from a wet product to the hot air. The hot air will be taken the moisture content of the product and goes out through the outlet chamber or any kind of chimneys provided in the dry dryer. Next one will be fluidization bed dryer. So in this the process is nothing but there is a phenomenon called fluidization takes over. The fluidization is nothing but the critical velocity will be more than the product which placed in the certain respective tracks or respective racks. So this holds the product in the suspension form, and the moisture content will be removed from the product and goes out through the chimney. So this is the fluidized bed dryer. And LSU dryer is nothing but Louisiana State University dryer. So this dryer is nothing but a continuous mixing type dryer. This is developed especially for paddy treatment because it ensures gentle treatment, good mixing, and good air to grain contact. So this consists of certain components like rectangular chamber, holding bin, blower with duct, grain discharging mechanism, and air heating mechanisms. So this system involves like layers of inverter V-shaped channels are installed in the drying chamber, and heated air is introduced through these channels so that the products can be come in contact with those hotter and the moisture content will be reduced. So these capacities can vary from 2 to 12 tons, and the recommended airflow rate will be 60 to 70 meter cube per minute per ton, and air temperature will be 60 to 85 degrees Celsius for both raw and paddy, parboiled paddy. And the design of dryers consists of three phases. First one will be preliminary dryer selection, and second one will be comparison of dryers. Third one will be final selection of dryers. So preliminary selection is nothing but we need to find out the physical chemical properties of the crop and drying characteristics of like crops like temperature, airflow rate. Those things we need to be determined, and product qualities needs to be determined in the preliminary dry selection, and the comparison of dryers like in the economical ways, and final selection of dryers will be done. To design a dryer system, we need to know mass and energy equations so that this is nothing but as we have seen in the earlier session, drying phenomenon is nothing but a heat and mass transfer principle. So whatever the energy comes in will be goes out. So like that, whatever the masses will be in and out is will be equal. So this is the basic formula like mass transfer and energy transfer. So by using this equation we can easily calculate any dryer, and this is the basic design for a drying system. Various factors which needs to be considered while designing a specific dryers for solar dryers or any other fluidized bed dryers. We need to consider specific factors respective to that dryer, and this is about psychrometric and drying. Thanks to all. We'll meet in the next session.